Hi friends, welcome back to your channel. In this channel, we try to solve the previous year's freeze question papers of NEET undergraduate exam. This is also helpful for JEE mains. This is solved in a very student-friendly manner so that you can understand and apply the concepts. We have included all types of questions which have appeared in the previous year's exams so that your preparation is complete. If you like the content, we urge you to like the video. This motivates us to create more content for you and help you in your exam preparation. We also urge you to subscribe to the channel so that you are immediately informed of any content added to the channel. If you have doubts, then please feel free to do add in the comment section and we will try to revert to you at the earliest possible. So without much ado, now let's get started. So in the previous videos, we have actually solved the first 10 problems of this topic. Okay, so this is a friction. We have solved first 10 problems in the previous videos. You can go and refer to the channel. You should be able to find them. So now in this channel, we will go from the question number 11 to the question number 15. Now, before we go through question number 11, I thought it might be more relevant to go through the question number 15 because this will give you a more holistic concept of how motion happens in a circular track involving all aspects. Okay, so in this case you can see that I have just drawn a motorcycle here. I have just drawn the motorcycle, the tire here. Okay, so in this motorcycle, this is actually on a this is a bank track. Okay, so now if you look at this, right, imagine that this is the motorcycle which is negotiating or which is going in a circular track like this, right? It's going circular track like this, and this is the radius of the circle, which is r. If you look from the top, this is a halfway loop, right? And the motorcycle is following this track like this. It is going on the track like this, right? If you see from the sideways, you will be able to see this, that it is actually a inclined track. So the road is not flat like this, right? The road is a little inclined like this, right? So this is 45 degrees. Okay, so this is 45. So this is 30 theta. Okay, the angle is not given here. Sorry, the theta angle is not given here. Okay, so the angle is theta here. Okay, and it's also given here that there is a coefficient of friction between this, right? Now imagine that when this particular when this motorcycle is traversing or going at a speed, what will happen? It will have a tendency to skid. It will have a tendency to skid. Okay, it try to go this way, right? So now there has to be friction which has to act in this manner, this way, so that this does not skid. Okay, so that it does not skid. The moment the force of movement is too high, the chances of skidding will be high because the friction can only help you to a certain extent. Okay, so if this is theta, so this is theta here. So as we said, the friction is actually acting like this, acting against the body, and acting against the body, right? The friction is acting against the body like this. If we imagine that this is a normal reaction. This is a normal reaction. Okay, let me write like this here, make it more easy for you to understand. So if this is the body, okay, this is the body, then this is mg. There's a weight acting here. Okay, this is mg. This is the normal reaction. Okay, so this is 90 minus theta. This is theta, right? This is theta. This is 90 minus theta. Okay, if you go like this, then this will be theta. So this will be n cos theta. Okay, now if the friction is acting like this, the friction is acting like this on the body. As we said, the friction is acting like this, right? Here also, if you look at this, the friction will be acting towards center. Okay, friction, if it is acting like this, so now what will this will be theta. Okay, So this will be f cos theta. Okay, this will be f cos theta. Fine. Then we f cos theta. So now here also, if you look at this body here, what will happen is that on this body, since there is a circular track here, so there will be centripetal force will be acting on this. And what will be the centripetal force? So I am writing centripetal force. Okay, the centripetal force, all of us might be knowing, centripetal force is given by mv squared by r. Okay, and if the body remains on the track, right, so there is centrifugal force also, right? There is centrifugal force. I'll mention as CF force. Okay, the CF force, if the body remains on the track, the CF force is also equal to mv squared by r. Okay, because it remains on the track. Okay, now let's come back to this now. So here we have here, okay, so n cos theta is equal to, if this is f here, we said if this is the frictional force, right, there is a frictional force here. Okay, let me put in another color here so it will be understandable to you. So there is a frictional force here, there is a frictional force here, and this 90 minus theta, right? Okay, so the n cos theta is on the top side. So n cos theta is on the top. The body weight is the bottom, plus friction, right? Friction is acting like this. Okay, so this is 90 minus theta. It means this is F, means mg plus this component of force along this line of mg. Okay, this will be F cos of 90 minus theta, which will become F sin theta. Okay, it means n cos theta is equal to, so n cos theta is equal to mg plus f sin theta. Okay, so this becomes my first equation which we need to follow. In this you took the vertical component here. Okay, now let's take the horizontal component. So if you look at this way, right here, so we said that this is n, this is 90 minus theta. Okay, this is n, and this is f. Okay, so n cos of 90 minus theta. Okay, cos of 90 minus, which will become n sin theta, right? So this will be n sin theta. Okay, and f of theta, f cos theta will be in this direction, right? So n sin theta, the component of n, and f's component of theta, a component in this direction, is n sin theta plus f cos theta. Okay, so let me erase a few things here. So n sin theta plus f cos theta. Now what is the force, centrifugal force here? As we said earlier, that there is centrifugal force is acting in the opposite direction, right? So there is a centrifugal force which is acting in the opposite direction. Okay, and what will that be? We said that centrifugal force is equal to mv square by r. We just mentioned that, right, sometime back. Okay, so it means n sin theta plus f cos theta will act inwards towards the radius. Okay, and this is equal to mv square by r. Okay, so this is the second equation. Now we just need to solve these two equations. Okay, so if you have to solve these two equations, right, so we have here n cos theta minus f sin theta is equal to mg. Okay, and this is n sin theta. You will divide that by that, right? N sin theta plus f cos theta is equal to mv square by r. Okay, m gets cancelled here. This is r. Okay, right. So this becomes rg by v square. Okay, so we have n cos theta minus b. So if you look at the answers are all given in terms of tan theta. So it means we will try to divide the numerator and the denominator by cos theta so that we get to the tan theta. Okay, so it becomes, if we divide n cos theta divided by cos theta, we're dividing both upper and numerator and denominator by cos theta. So we will get here n minus f sin theta divided by cos theta becomes f tan theta, right? F tan theta. Okay, n sin theta divided by cos theta becomes n tan theta. Okay, f cos theta divided by cos theta becomes f. This is equal to rg by v square. Okay, so what is equal to frictional force? Frictional force, we all know from the previous examples, is that F is equal to mu n. Okay, we know that F is equal to mu n. We would have seen the frictional force to say that mu n. Okay, so it means n minus mu n tan theta upon n tan theta plus F is mu n is equal to rg by v square. Okay, so this is what we have till now. Okay, we'll try to clear some space here. Okay, so we will divide both numerator and denominator by n. So we have here 1 minus mu tan theta upon tan theta plus mu is equal to rg by v square. Okay, so we need to find the speed, right? So v square is equal to rg. Then we have mu plus tan theta on 1 minus mu tan theta. Okay, so what will be so v square we have is this thing, right? So we have mu plus tan theta divided by 1 minus mu. So what will be v? V will be the square root of this one. Okay, v will be the square root of this one. Okay, so the answer will be the first option. So the answer will be the first option. Okay, so I hope this is clear now. This I wanted to cover so that it actually helps you. It actually helps the concept, helps you understand the holistic view of this, right? So now we'll go back to the previous problem. Okay, question number 11. Okay, so we'll come back to this problem now. Question number 11. In this question, it is given that a car is there, which is again on a bank curve, right? And what is the banking here? Which is 45 degrees, right? So it means that this particular road is actually not flat, right? It is actually inclined to the horizontal by 45 degrees. Okay, and one important thing is that we cannot see friction in this. So friction is absent, friction is not there. So this is frictionless. Okay, so it means we have to ignore mu, okay, in this case, right? So now if you look at this car, then we saw earlier that the normal reaction will be like this, right? And this will be theta, okay, and this will be mg. So it means n cos theta is equal to mg. Okay, right? And also we saw earlier that this component the other component, so this is n sine theta, this is n cos theta, and there will be other component vertical to this, right? This will be 90 minus theta, okay? So this will be n sine theta, okay? N sine theta, n cos of 90 minus theta is nothing but n sine theta, okay? And this will be actually, so as we said here, if the car is moving like this, okay, and if the car is located here, okay, so there will be a centrifugal force here and there will be friction, okay? The friction will act like this, and the centrifugal force would act in this direction, okay? And what is the centrifugal force? Centrifugal force, as we mentioned in the previous problem, it's equal to mv square by r, okay? It means F, so in this case, the force is, in this case, there is no frictional force, right? There is no frictional force here, okay? So in this case, we have n sine theta equal to mv square by r, okay? So if we just divide this equation by this equation, it becomes n sine theta by n cos theta is equal to mv square r upon mg, okay? This gets cut here, but it means tan theta equal to v square by r g, okay? So tan theta is this angle is 45 degrees, so tan theta is equal to 1, okay? It means v square is equal to r g, okay? What is the radius? The radius is given to be 40 meters, 40 into, and what is the g? G is 10 normally, this is 400, okay? So v square is equal to 400, so v is equal to root of 400 is equal to 20 meters per second. So this is the answer. Normally, if by any chance they do not provide you the value of g, then you can take it as 9.8 or 9.8 normally, okay? So in this case, so the answer to this is the first one. So the answer to this is the first one here, 20 meters per second, okay? I hope that is clear to you. Now we'll move to the next question. A car is moving in a circular horizontal track of radius 40 meters, okay, with a constant speed of this thing. Now in this case, if you notice, that there is no banking. There's no banking, okay? It means that the road is flat. If you remember the previous problem, we had the car moving on the incline like this, right? Correct? Normally we had, right? But in this case, that is not there, okay? So we can just ignore this. This will be a simplicity here, okay? So here also, so now what happens? Let's imagine that what will happen to this particular bob here, okay? Now, as this moves like this, right? The car is moving like this. Again, this is a radius, okay? This is a radius here. This is a radius of the circle. This is the force which will act on this, right? So if this is the body, this is the car, okay, then this will be the centrifugal force acting outwards, okay, and we'll have the radial force. We'll have the radial force, the centripetal force acting towards the center, okay, mv square by r there, okay. So now let's look at this in more detail, because this entire question is all about this particular pendulum, okay. So let's look at originally this will be vertical like this, right? This will be originally vertical. This is vertical. This is hanging on top of the car. It's given to us, right? Now when this when the car is moving around this, then what will happen is that because of the centrifugal force, this thing will actually go this side, right? It will go outwards to this, right? So what will happen is that this will actually go like this. Okay, this pendulum will go like this. Okay, there will be a tension on the string. Okay, so now what is the force acting downwards? This is equal to mg. Okay, right? And imagine that this is t and this will be theta. Okay, will be theta. So this is theta. Okay, so this is the tension on the string because now the bob has moved like this. It was initially this thing. When it has gone this side, when it has gone this thing, so because centrifugal force is actually pulling out, pushing it outwards. Okay, imagine the track was like this. If the track was like this and if it is going like this, then what will happen is that it will happen just the opposite. This string will come like this. Okay, same thing happened, but it will change. Okay, I'm just giving example. Imagine that if it was going like this, then this scenario will happen. Okay, but since it's going on this side, this will happen here. Okay, fine. So coming back to this now, so we have t cos theta is equal to mg. Correct. So t cos theta is actually same as mg here. Okay, and what happens is that now there is a centripetal force here, mv square by r. This centrifugal force here, mv square by r. Just keeping it constant. Okay. So now t sine theta. This is 90 minus theta. Okay. So t 90 cos of 90 minus theta. So it means if you look at the bob like this, this t cos 90 minus theta, which is t sine theta. This is equal to the centrifugal force. Okay, t sine theta is equal to mv square by r. Okay, so it means we have t sine theta is equal to mv square by r, and we have t cos theta is equal to mg divided by, we just divide these two, right? Divided by mg. Okay, this is equal to, so t cuts, right? So we have tan theta is equal to p square by r g. Okay, now what is given to us is that the velocity is 20, so 20 square, which is 400, radius is 40, and g is 10. Okay, right? So this is equal to 400 divided by 400 is equal to 1. It means tan theta is equal to 1. It means theta is equal to 45 degrees, because we know that tan inverse 1 is equal to 45 degrees. Okay, so theta is equal to 45 degrees, so this should be the answer. Okay, so the angle, this should be the answer. So now we go to the next problem now. Okay, now we go to the next problem now. What is the maximum speed of safe speed of a car on a road of 20 meters per, on a road of diameter, on the road of radius 20 meters, if the coefficient of this is given, this thing, right? So here we have here, so this is circular track on which again the car is moving here, correct? The circular track, again the car is moving like this here, on the circular track like this, it will go on like this, correct? Now what is the frictional force on this? We saw earlier, right? So the frictional force F is equal to m v square by r, because this is centrifugal force. Okay, so F is equal to m v square by R. Okay, this is the frictional force. Okay. Now, what is frictional force? Frictional force is normally mu mg. So mu mg is equal to mv square by r. Okay. So we need to find what is the coefficient of friction. So mu is equal to again v square by r g. Okay. What is the velocity given? Sorry, in this case we need to find the speed. Okay. So v square is equal to mu r g. Okay. Now v square is equal to mu, which is 0.5 into r, radius is equal to 20, and g is 10. It is given to us, right? So 0.5 into 20 is 10, 10 into 10 is 100. This is again 100. Mean v is equal to root of 100. Okay. So v is equal to 10. Okay. So the answer to answer is actually answer. Okay. So I hope you are able to follow this question. Okay. Now let's go to the next problem now. Right. So in this case, it's given that two bodies of mass m and 4m, okay, are whirled in horizontal circles. So imagine that these are two horizontal circles we're talking, right? So two horizontal circles. Okay, so one circle is this circle 1, and this is circle 2. Okay, two bodies of mass m and 4m are whirled in horizontal circles, right? So two bodies, one is this body is on this circle, rotating like this, and the one body which is rotating in this circle like this, right? And the other body is rotating in this circle. Okay, the heavier one in this thing, so I can say that this is the heavier body is here, and this is a lighter body. Okay, I can say that is a lighter body is here. Okay, so this is r by 4. This is given that this is r by 4, and this thing, the bigger one is actually r. The bigger radius is r. Okay, the tangential speed of the lighter one, so I can say that tangential speed VL, I can say, is k times the value of the heavier stone. Okay, the VH into k. I can write that k into VH. Okay, right? Okay, and they experience the same centripetal force. The centripetal force is the same. Now, what is centripetal force? We know that it's mv square by r. We know that this is the centripetal force. So it means that m heavier body into v h heavier body square by r heavier body rh is equal to m lighter body v of lighter body square divided by r lighter body. Okay, because given the centripetal force is the same, so this is the centripetal force for the heavier body, and this is the centripetal force for the lighter body. Okay, so now we can just substitute this, right? The lighter body mass is m, the heavier body is 4m, right? So we can write that. Okay, lighter body, so heavier body is 4m, right? 4m into VH square. Okay. Also it is given to us that the tangential speed of the lighter stone is k times that of the value of the heavier stone. Okay, so it means if the heavier stone, if the heavier body, if that has a tangential speed of, say, for example, VH, then VL is equal to k times into VH. Okay, right? So I can write that 4m into, I can write the VH is the heavier one. Okay, so I can write this like VH square divided by, now what is the RH? Radius, radius of the heavier one, the circle of the heavier one is R by 4. Okay, this is equal to the lighter one now, right? The lighter one mass is m. And now, what is the lighter body's velocity? It is k times the heavier one. Okay, so I can write there is k vh whole square divided by, what is the lighter body's radius? That is r. Okay, fine. So this is where we are now. So m gets cancelled here, r gets cancelled. Okay, it means we have 4 VH square. So this 4 will come on the top, right? Come on the top. So this will become, this is actually not 4, this will become 16 VH square. Okay, is equal to k square into VH square. Okay, so VH square I can cancel. So k square is equal to 16. So k is equal to 4. Okay, so the answer will be k is equal to 4 here. Okay, so this is the answer. Okay, so with this we have solved all the problems in the friction series. Okay, so friends, we have solved all the problems in this now because this is solved earlier itself. So friends, we hope you like the solution to the problems. If you do not like them, please add your review comments so that we'll try to improve upon them. But if you like them and if it is helping you in any way in moving you forward towards your exam positively, we request you to like the video and subscribe to the channel. Okay, we hope to see you back in the channel. So thank you friends.